Hello, we are at the module 40 of NOC course in symbolic logic. This is the end, the last module of the series in which you are learning about this subject, symbolic logic. I have explained what multiple quantifier situation is in our last module, and what I am going to do now is sort of put some more refinement on that, the multiple quantifier situation, specifically the one where there are more than one quantifier sharing a predicate, and therefore sometimes sharing the scope also. So, embedded scope, sharing of a predicate, and more than one quantifier. That is what we are going to look at. So, that overlapping quantifier situation is going to be our last concern, and we will try to read it together, and that should give us some idea about how to handle the syntax of statements where there are more than one quantifier present, and this is where we are going to draw the line on first order predicate logic. Remember, we have just talked about the syntax of first order predicate logic. We could not give time to the semantics or the proof systems of first order predicate logic. Maybe in some future, maybe we can expand the course to cover those also, but right now we are looking into the advanced level syntax of first order predicate logic. So, overlapping quantifiers, what to do with them, and so on. As I said, that sometimes the quantifiers may be overlapping, sharing predicate as well as the scope. We are not just talking about the presence of quantifier in a given statement, So, we are not just talking about same sentence with many quantifiers, but we are actually saying the same predicate is being shared by more than one quantifier. And you can imagine that is very likely to happen in case of the two place predicates. We have seen some samples, two place or n place predicates, right. We have seen some samples in module 39 also. But this is to bring the matter to the sharpest of the focus by, say, examples like this. You have for all y, there exists at least one z such that z is g to y. GZY means z stands in G relationship with y, right. How to read that, and what does it mean? And in this case, as you can see, both the quantifiers rule over the same predicate, and notice that the scope is also kind of within one another. And here also, keeping the scope separate or giving the scope enough importance to understand the predication is going to be quite important. In this case, there are two quantifiers, but as you can see, there is one main quantifier, which is the first one, the for all y. Why? Because it has the maximum scope. The quantifier with the maximum scope will be the main quantifier. Just as we discussed in propositional logic, the main connective is the one which has the maximum scope. In here, what is the scope of this for all y? As you can see, it starts from here and it goes all the way up to here. How? Well, as you can see, the y, there are two occurrences of y here. One is with the quantifier expression itself, and the other one is adjacent to the quantifier. Now, this happens to be adjacent to this quantifier also, right, but this y is within the coverage of this main quantifier. The other quantifier that you see here is what we will say the sub quantifier. This one is the main and this one is sub, because it does not have the maximum scope, and its scope lies within the scope of the main quantifier. Now, what is the scope of this? There exists at least one z. Take a look. It starts from here and it ends here, right? Now, see, the same predicate is within the scope of two quantifiers. Get me? And this is the kind of situation that you are going to see more and more. This is where we need to really work with the quantifiers themselves, the scope, and so on and so forth. So, in both cases the scope ends with g z y, but this one has a smaller scope, as you can see, and this one has a larger scope, right? Yeah. So, this is what we would call not just multiple quantifier, but this is a overlapping quantifier. As you saw that in the overlapping quantifier situation, we had two quantifiers lined up one next to the other, the sequence. Now, sometimes this sequence is not important. The weightage of one quantifier is not over the other. Okay, let's take a look. Sometimes this sequence is not going to matter that much. Suppose we have this sentence in front of you. The UD is restricted and it's restricted to natural numbers, fine. So, there is no property called being a natural number, because the domain is full of natural numbers only, right. And the only property that we are allowing here is g x y, which stands for x is greater than y. That is a two-place predicate. There we have to express some natural number is greater than some other natural number. Okay. Take an arbitrary, there is at least one, this sum is there is at least one, there exists at least one natural number such that it is greater than some other natural number. When we say some other, we are referring to two different individuals, right? Two different individuals without naming them. So, unspecified, therefore, we are going to need quantifiers. How many quantifiers? Two. One is greater than the other, correct. Now, this is where, as you can see, there will be a overlapping quantifier situation sharing the predicate, namely g x y. Take a look. The translation should be easy. You probably already will do this. Does not matter whether you are using y z, you can use x y, you can use u v, but the matter stands. So, there exists at least one y and there exists at least one z such that y is greater than z. Now, in here, will it matter if I put the z first and the y next, the sequence? The answer is no, it does not matter, because all we are planning to say is that some natural number is greater than some other natural number. Both are unspecified. Had it been a specified individual, okay, if you wanted to say 12 is greater than 9, that is a different story, right. 12 is greater than 9 is not equivalent to saying 9 is greater than 12, correct. But there we would not be using quantifiers. 12 and 9, these are completely specified individuals, unique individuals in your natural number domain. So, you should have used constants, individual constants instead, but here the reference is unspecified and we are referring to unspecified individual. We want to keep the reference unspecified. So, which is why we are using the quantifiers. All I am saying is when you have some connected to some other in your domain, the sequence of the quantifiers is not really that important. Either way you can make sense of that. So, the sequence in this case will not be important as opposed to other cases, which I am going to show now, that there the sequence is going to be quite important. Similarly, when you have two universal quantifiers lined up ruling over the same predicate b x y, if you interchange this quantifiers, it is not really going to matter much, the meaning is not going to be hampered much, right. If you want to keep it that everything in your domain is connecting to every other y in this way, then that so be it. So, when you have this kind of same quantifier, same kind of quantifiers lined up, the sequence is not that important, could be important, but it is not that important as in the case when you have a mixed sort of a quantifier. Mixed sort of quantifier, why? Because the first one which comes determines the meaning, that is the main quantifier, and it changes the meaning, because the whole emphasis is on the main quantifier. So, if you make the sub quantifier the main, the meaning changes. Take a look. Again we have the same UD, natural numbers, and we have gxy, which is x is greater than y. There, if your sentence is every natural number is such that there is some number or other which is greater than it. Okay? In other words, what you are trying to say is true about the natural number series, that for every natural number there is at least another number which is greater than it, which is why we say there is no greatest natural number, right? There is no such thing. So, that is what we are trying to explain, that take any x, if x is a natural number, then there is some other natural number which is greater than it, right. First of all, notice that we unspecified references to natural numbers, and there are quantity terms, two quantity terms, every and some number or other. Every stands for the universal quantifier. Some number or other would refer to existential quantifier. And here we are not, or we cannot use the same variable. If you use the same variable, what will happen? The meaning will be destroyed, the scope conflict will be there, and you cannot make out what is being said in the sentence, right. So, but what is the translation of this? Translation might be like this. Now, again it does not matter whether you are using x y instead of y z, I have used y z. So, this is for all y there exists at least one z. Remember, the UD is natural numbers. So, we are referring to natural numbers only. So, for all natural numbers there is at least one natural number such that that z is greater than the y. Okay. This is one kind of a thing where you, if you, the point that I am coming to, that this sequence here is important. Just see that if we change the sequence, you are going to give rise to another sentence altogether, which says there exists a natural number such that it is greater than every other natural number. What have we done? Change the position of the quantifiers. Take a look. Now, we have there exists at least one z such that for all y g z y, and this sentence reads as there is such a number such that it is greater than every other natural number. Okay. So, as you can see, the two sentences are different. So, the sequence changed that, and this is not equivalent to saying this, right. This one is true. If you know anything about the natural number, then this is true, but this is this is false and this is true, right. There is nothing called the greatest number, and this is perfectly okay with the natural number series. Now, what we need to learn from this, the takeaway from all of this, is that the sequence of quantifier can be very important. It changes the meaning, the emphasis, the way to read the sentence. You change that if you change the sequence. So, there are cases when tampering with it is going to really matter, and those cases specifically are where you have a mixed sort of quantifiers. There is a mixture of universal and the existential. Okay. Now, how do we read the sequence of quantifiers is like this, that when you have only the existential, the way to read it is there exist some y and some z such that etc. Okay. This is for all y or every y, there is some z such that, etc., some z or other. Notice that this is somewhat loose, some z or other, there is nothing definite, because the way you put it in the second position, it sort of relegates it to a rather loose interpretation. The main thing is this: for every y, some z, there is some z or other, there exists some z or other. This, on the other hand, is emphatically saying there exists a z such that for every y, etc., etc. So, this is where the emphasis plays, and this is where for all x and for every y such that, etc. Okay. So, we have covered what is known as the overlapping quantifiers, and where they are sharing the predicate as well as the scope and so on. Now, the last thing that on our agenda is to sort of put it all together, all this knowledge that we have about multiple quantifiers, about reading the predication correctly, about the scope and so on. Let us try it out with a complex sentence like this: the sages never tell a lie. The sages never tell a lie. Is that a quantified sentence? Can we use quantifiers here? Are there quantity terms here? Because we do not find any all, we do not find any no, we do not find any some. But with your keen eyes, I am sure you have noticed that there is tremendous possibility. Let us take a look, first of all, what we have here, the properties. Lx is x is a lie, Tx x is a time, Sx x is sage, Tx y z, that is a three-place predicate, x tells y at z. Okay. How many kinds of things we are talking about? We have the sages, we have the lies, right? And in this never, we are referring to what? To time. You see? So, that should tell you that we have three kinds of things. Three kinds of things mean we are going to need at least three kinds of quantifiers. How many of these things, right? So, sages is one, never, as I said, never as in not ever, no time. So, time is one kind of thing, and then there are the lies. Okay. So, those things. Three quantity terms are there, in case you have noticed. If you haven't, let me help you. There is the sages. That article means something. It is to be interpreted, but it is a quantity term. Then there is obviously the never, that is a quantity term, and then there is this article again called a or a. How to interpret that, those things? At this point, let me tell you, you have three different things. You have three different choices how you are going to read this sentence, how you are going to see the predication, right? You can start with the sages as the main group and say that we are talking about the sages about whom the rest of the sentence is predication. So, sages are such that they never tell a lie. Get the predication. Sages is the subject and they never tell a lie, are such that they never tell a lie. The whole thing is predicated to the sages. But you have a choice. You can also go with the time. Time. Instead of going with the sages, you can target time as your main subject. All times is such that sages never tell a lie, or better yet, no times are such that the sages tell a lie at that time. This is one kind of predication. Or if you want, you can also start with the lies. So, all lies are such that the sages never tell them. Get me? So, now this is the kind of liberation that you have achieved. This is the kind of freedom that you have achieved after learning all that predication and first order syntax, this, that. Where do I start? Okay, and you can start, I am telling you, you can all you need to do is to fix one subject group, and then the remaining predication can be done very easily. Now, suppose you are starting with the sages, then you are saying that the sages are such that, etc. Here, what do you mean by the? One particular sage, at least one sage is such, or all sages are such. You are right, it is all sages are such that, etc. So, you understand, if you are going with the sages, you are going to need a universal quantifier to start with. When you said never, and I already told you, never means no time is such that. So, even here you have a reference to a universal quantifier. And then a lie. How many lies you want the sages to be telling? Not even one. Okay. So, a here is at least one or some. Let us work with the paraphrase, because that is where we are going to spend some time. So, we are starting with, for any x or for every x, if x is a sage, then x never tells a lie. That is the first thing to do. So, we have fixed the subject term, and then the remaining predication we have put together. Now, let us break this part, keeping this part constant. So, for any x, if x is a sage, then x never, never means what? At no time. Okay. So, then we go like this, for any x, if x is a sage, then for every y, if y is a time, if y is a time, then x does not tell a lie at y. Okay. So, once more, for any x, if x is a sage, then for every y, if y is a time, then x does not tell a lie at y. We have kept the a lie untouched. We have only unpacked the never in this sentence, keeping the first part and the end part intact. Did you understand? Next is then a lie. So, we keep it all together, for any x, if x is a sage, then for every y, if y is a time, then for all z, if z is a lie, x does not tell z at y. So, all lies are such that x does not tell them at y. Let us see. This part, notice that we can rewrite, if you recall the contradiction relation, then this is E. We can also replace it with negation of I. So, this part we can rewrite it also, it is your choice, whichever way you want to go. You can rewrite it as, it is not the case that there is at least one z such that z is a lie and x tells z at y. Once more, you can go with the E. So, for all z, if x is a lie, x does not tell z at y, this is the not, or its equivalent is the I proposition, but it is negation of I. It is not the case, that is a negation, that there is at least one z such that z is a lie and x tells z at y. Let us take a look into the translation. The translation may look like this: for all x, if x is a sage, then for all y, if y is a time, then for all z, if z is a lie, then x does not tell z at y, right? Or we said its equivalent. Fine, the equivalent would be something like this: for all x, if x is a sage, then for all y, if x is a time, then it is not the case that there exists at least one z such that z is a lie and x tells y. Okay, sorry about that. So, x tells z at y. All right. So, this was our sages never telling a lie with the sages, but the grouping. If you are starting with time, then how do we do that? Remember, then time becomes the main subject. So, there is no time such that sages tell a lie at that time. This is what we will say. So, the paraphrase will look like this. It is not the case that there is at least one time x such that for any y, if y is a sage, then there is at least one z such that z is a lie and y tells z at x. And the translation would look either like this or like this, because they are equivalent. This is, it is not the case that there exists at least one x such that x is a time, and for all y, if y is a sage, then there is at least one z which is a lie and y tells z at x. The whole thing changed. Why? Because we started with time. No time is such that, or it is not the case that there is even one moment of time when the sages would do this. This is the equivalent, except that it is a E proposition. So, you are starting with universal quantifier and the tilde would appear at the consequent, because that is what the E propositions do. This is just to give you an idea how to handle this complex and overlapping quantifier situations. See, did you see that there are embedded quantifiers in it, and we are ruling over the same predicate. So, each one sort of is connected, right. It is not a very clearly separate scope, no conflict and so, but even there we have to ensure that the variable that we have chosen for one group, and we keep the reference to that group alive until it is needed. So, in this case the whole 3 plus predicate appears at the end of the proposition. So, the quantifiers also remain, the scope remains open until the very end. That brings us to the end of our lessons. I hope you have learned something out of this. I really hope that you will be able to use it somewhere in your studies or in your further research maybe. And it's always hope that we will be able to expand this course more, and that there will be a greater utility coming out of it to each of you. So, all the best to all of you, and thank you very much for your time and patience. Enjoyed teaching you. Thank you very much. Bye.